So we are here at the Rocky Mountain RMRRF Fest in Loveland, Colorado, and it is turtle time because we're here with the Box Turtle team, and they have more than just a MMU system now, kind of, sort of. You have some other stuff. They have some other stuff. This guy's going to tell you more. Let's start. So we got Robert here, and he's going to lead us away. So let's start.
So I'm the lead designer at Armored Turtle, and obviously Box Turtle's become very successful and really got our name out there, but we also want to demonstrate that we can do more than just multicolor systems. So we've been working on a printer. We call this AT2. It's for Armored Turtle 2. And the design goals here is high temperature printing, like polycarbonate and above. This chamber is completely sealed. Everything from the ground up is brand new on this printer, original design. So what we've done is we've isolated the Z drives. Obviously, it is a flying gantry with a brand new belt path that is more or less unique. Currently on this development unit, we are using the VZ-Bot print head. That will be changing as we get into more CNC parts for it, which obviously will be coming with elevated print temperatures. Just running ABS at normal 105 bed to 60 nozzle, the chamber will hit about 85 C. It'll peak out at around 100 C. And how we've done that is just really isolating the print chamber as much as we can without getting into too much advanced insulation materials.
So you are able to hit over 100 degrees Celsius in this chamber with just the bed heater, essentially.
There's a series of fans under the bed using it as a PTC heater for the chamber, yeah.
Okay, so you're circulating the air, heated air off of the bed, and you're getting those chamber temperatures. That is pretty insane. And also the printer itself being relatively compact and sealed up extremely well helps a lot with that too, correct?
Yeah, absolutely. That's a part of the form factor, was to keep the print volume small so that we could heat it effectively.
And so right now you are printing ABS, but yes, you're aiming to be able to print quite a bit of the engineered materials, correct?
Polycarbonate and above. The hot end can technically do 500. The bed that will be on it will be able to do 150 sustained. Actually, one of the problems with ABS is it's getting so warm in the chamber that it is staying at glass transition temperature.
Oh, so like the print as you're laying it down is really
if
not
you reached
solidified
in there and touched it, it would be soft.
It would be, yeah.
Yeah.
And I also see you have something on here that not really a lot of printers have. You have water cooling.
Yes, so when you're dealing with elevated chamber temperatures, you can't use air to cool the heat break. The filament will start melting up to the extruder. The only way around that is to water cool it.
What else can you tell me about the electronics in here? Because we're looking at, this is the LDO Leviathan. It also has the expansion board, is that correct?
Yeah, that's correct. That's so we can get the 4 5160 drivers for the all-wheel drive gantry in this printer.
Okay, and what are you using for part cooling on this machine?
It has a 12K RPM 5015 fan in the back of the tool head.
And what else is there? Is there anything under here, or is it just motors? Like it's just
this is to double isolate the chamber as much as we can.
Okay.
Obviously, with these 3 ones, that's our biggest heat loss. So everything that we can is double insulated.
And if somebody's looking to build one of these, will instructions be online? Will it be open source? Will kits be available?
It'll be just like Box Turtle with the online full 3D render manual and all that, open source, GitHub, when it's completely done.
And kits, maybe?
People have been talking to us about it.
Okay.
So we'll see.
Awesome. And then we also have some other stuff here at the booth. What can you tell us about this guy?
Okay, so when you're doing a multicolor system like Box Turtle, one of the biggest challenges is cutting the filament or doing tip forming. Tip forming is a tedious process to tune for most people. So you go with the cutter. Cutters have their own problems. Usually if you're using the kinematics of the printer to bump the cutter, sometimes you can cause skips. You also have to tune the position and the retract and all the distances to interface with that. So what I've done is I've been working on an electric filament cutter. It actually fits in a very small package. It just goes between the extruder and the hot end. So if you're using like Orbiter, Sherpa, it just bolts right in between. All you need is longer bolts.
And you have a demonstration
I do have a demonstration.
So push the little button and it'll
pull the filament up, cut it, and then send it back down.
There you go. So that'll be pretty simple. So for that to work, obviously now we're going to need some electronics. So what's the requirement for that?
Okay, so to fit in its very tight form factor, there's some proprietary electronics and the mechanics of it are very small. They're not going to be DIY-able. This is going to have to be a product type situation.
Okay. And then for plugging it in, we got 4 pins here. So what kind of compatibility?
Right.
Like, will you be able to plug this into like an existing tool head board, for example?
So it's got its own firmware on it for error handling. It'll be firmware agnostic. You just need to execute a pin high macro, tell it to cut, and then it'll send the other pin.
Okay.
Say I completed. Or if it doesn't, then there was an error.
Okay. And 5 volts?
5 volts or 12 volts.
Okay. So as long as you have a 5 volt pin and a signal pin available on your tool head board, you can use it essentially.
Yeah.
Okay. So what is this guy though? Because this is wee. It's petite.
Yep.
What is it?
So it's a suspiciously small print head. That's where the name came from. The problem I had was I had a micron and I wanted to put a box turtle on it, and there was no really good options for cutting on printer for ant tool head. I tried a couple with Dragon Burner and just had problems. And so obviously I love the design of the Stealth Burner. It's clean, it looks good, but it's big. There's no way that fits on a micron. And so Kevin, aka Sam, shout him out, had designed WTH burner, an almost finished project. And I saw that and said, you know what, we could turn that into something awesome. So took from what he had built, added the Filomatrix geometry to a cutter, changed the face to use a 3010 fan. It's a little more common. This uses full-size NeoPixels, so your regular hardware. It's got a filament sensor in it, as well as this is sort of now the primary extruder is using HTX gears, so super consistent extrusion. It works great on multicolor systems, super forgiving. So, the goal was I want a small tool head that's got a cutter that is clean and has great wire management. And that's where this came.
So that is the sus burner. And then this is something you might have seen already. This is essentially a box turtle with a DIY enclosure and filament dryer.
Yep.
And this just uses the Polymaker dryers essentially, right?
Yep. And the goal here is really for not to be a dryer,
It
but
just
to be
kinda
a
keeps it
maintainer.
a
Exactly.
maintainer.
You take your filament and out of your real dryer where it's now bone dry, drop it in here and it's not going to get wet.
Okay.
And that's the goal. And it seals so well that once you run it out, you get that humidity to 10%, it'll maintain it for a long time.
Excellent. So, more than turtles here at Box Turtle. Cheers. Coverage for this year's Rocky Mountain RepRap Fest is sponsored by LDO Motors. For printer parts, kits, accessories, and more, check them out at the link in the description.
Now it's on. Now it's on.